Good afternoon. I think you can hear me. So just put me in the chat box if you're able to hear me. Okay. Can I see the screen? Can I see my screen? I have shared my screen. Okay. Fine, fine, fine. Still many people are not joined. All right. So uh, if you have any problem, you can put it in the chat box. I can see the chat box. Okay. So if anybody want to talk also, we can ask any doubt using chat box. Okay. So today, let us start with the new module. That's a module 2. Okay. Okay. So module 2. I hope screen is moving. You can see that. Can you see the second slide? Syllabus I have displayed. Can't hear me. What about now? Can you hear me? Can you hear me? Okay. I'm audible. Fine. Thank you. All right. So now, in the second module, we are going to discuss about elastic properties of material. Elastic properties of material. Okay. Then in the elastic properties, what are the things we are going to discuss? That is concept of elasticity, plasticity, stress strain, tensile strain, shear stress, and all those things. Then of course we are going to discuss about Hooke's law, then different types of elastic modulus and relation between them. Okay. Then next we are going to discuss very important thing which is application in engineering, that is bending of beams, bending of beams. Neutral surface, neutral plane, derivation, bending moment, all this can be seen. Okay. Then of course we are going to discuss about torsion in the cylinder also. So what is a reference book for this module? We are going to use references engineering physics by uh, Gauran Gupta, and introduction to mechanics by Varma. These we are going to use. Okay. All right. So I'll launch a poll. Okay. Just to understand. Okay. Just to understand, I am doing this. Okay. Pole. Okay. You can say this. Okay. Just for understanding. Here afterwards, every now and then you will get a poles. Just mark that. So, all right. So that will run in the corner. Next, we see how exactly things are going. Okay. Introduction to velocity. So let us see one by one. What exactly elasticity? Let us try to understand. Before going to elasticity, whenever you apply a force, any extent of force, whenever you apply, uh, if body doesn't deform, then the body is known as a rigid body. The body is known as a rigid body. Okay. So now, but all body cannot be a perfect rigid body. All bodies cannot be perfect rigid body. So whenever you apply, most of the bodies, okay, most of the bodies, what exactly happens is they undergo deformation due to the external deformation force. Whenever you remove the force, they will regain the original shape and size. If there is a 100% recovery, then body is said to be perfectly elastic. Okay, perfectly elastic. But of course, there will not be a 100% perfectly elastic body. You cannot see that. You cannot see such type of body. Okay, so that means uh, what exactly happens is so all practical bodies are not perfectly elastic. But of course, these bodies, material are known as elastic material. The force is called as elasticity. Okay, all right. Next, then all practical bodies are not perfectly elastic also, and not completely elastic also. A body which does not regain its original shape or size, even when the applied force is removed, then body is known as perfectly plastic. If that is whatever deformation takes place, if it is completely maintained, then the body is known as perfectly plastic body. Perfectly plastic. Okay. So, all right. Still okay. Many have not answered the poll. Just I am verifying whether you are able to uh, use the polls. Please use that. Still 12 members has not answered. 1 minute left. All right. All right. So therefore, no body or material in nature is either perfectly elastic or perfectly plastic. Nearest approach to perfectly elastic body is quartz crystal. So its Young's modulus is so modulus of elasticity is very high. It's difficult to deform, but of course it can also be deformed. So therefore, generally we take nearest to perfect elastic body is quartz crystal, and perfect plastic body is putty. So if you deform, it will it will not regain original shape or size. Okay, original shape or size. Okay, now let us see what exactly stress. What exactly stress? When a when a force acts on a body producing deformation, then what exactly happens? What exactly happens? So what exactly happens is you can see that the body undergoes deformation because of the external force. Okay, but internally there is a opposing forces developed that is known as a restoring force. There will be a internal force. There will be an internal force which is try to regain the original shape and size of the body. That internal force is known as a restoring force. Restoring force. So you have studied in simple harmonic motion, same thing. So it is a restoring force. So therefore, this force, whatever internal force, that is known as stress. That's known as stress. Okay. All right. So let me see. People say voice is breaking. Let me check that. Okay. Okay, let us see that. Okay. All right. So there is it's not an issue with the software actually. Maybe issue with the internet. Okay. All right. Let's see. So okay. So therefore, mathematically, stress can be defined as restoring force per unit area. Okay. So restoring force is dependent on what area, on what area, on what area force is applied. Force is applied. Okay. So therefore, cross sectional area, internal as well as external, both are important. So therefore, we can say uh, restoring for unit area stress is equal to F by A. SI unit of restoring force per unit area can be written as Newton per meter square. Okay, Newtons per meter square. All right. Okay, that is how stress is defined. Okay, so people are saying there is issue. What I will do is I will stop sharing. I will come back to original screen. Let us. Okay, one of you can unmute and speak what exactly happening. Yes, you can unmute now. I will unmute all. You first you mute, then one by one you can. If there is a noise, I will unmute all. Okay. Then immediately you mute it. Then you can. Yes. Yes. Any one of you can unmute and tell what is the
ಇಲ್ಲ
problem.
ಕರೆಕ್ಟ್ ಬರುತ್ತೆ ಅಲ್ಲ ಇಲ್ಲ ಗೊತ್ತಾ
Yes. What is the problem? Yes. Any one of you can unmute and tell what is the problem. Yes. I have given the privilege to unmute, right? Can't unmute. Okay. Yes, now you unmute. Mayur? Mayur. Yes, I can see people are, whenever I unmute, you are muting again. So therefore, it's possible to mute and unmute. Okay. Let me continue with the class. All right. So mathematical expression. Uh, yeah, no problem. You can put it in the chat. Any problem? An external force is applied. Okay, that is we have seen this. Next, let us see what exactly different types of stress. So there are different types of stress. There are normal stress, then shear stress. Again, in the normal stress, there are two different types of stress: tensile stress and compressive stress. Tensile stress and compressive stress. So normal stress, what is the meaning of normal stress? Normal stress is if the deforming force acting normal to the surface of the body, the force per unit area is called normal stress. Okay. If the deforming force acting normal to the surface of the body, the force per unit area is called as normal stress. Okay. So there are two types of normal stress. One is tensile stress. Tensile stress. Another one is compressive stress. Okay. Tensile stress means two equal and opposite force are acting on a body. That's known as tensile stress. Tensile stress. So, for example, if I take the pointer and I'll show you. See, if this is the body, okay, let us say this is the body, some body. So, force is acting in this direction, another force is acting in this direction. So that means you are pulling perpendicular to surface of the body. This is a surface of the body. This is surface of the body. So normal force is acting normal. That is what exactly. If the deforming force acting normal to the surface of the body, uh, the force per unit area is called as normal stress. What is tensile stress? Tensile stress, it is induced in the body when subjected to two equal and opposite pulls. That is what exactly I have shown. Two opposite pulls. The effect is known as tensile stress. Effect is known as tensile stress. Okay. So then what exactly compressive stress? Compressive stress. Compressive stress is, so then the body is subjected to two equal and opposite push. So that is compression. Okay. This is in this direction. Again opposite, but it is not stretching, it is compress. So then it is known as compressive stress. Okay. Both are equal and opposite. One is stretching, pull, another one is push. Okay, so then it is known as compressive stress. Then another one is tensile or shear stress. Tensile or shear stress. If the deforming force acting tangential to the surface of the body, then force per unit area is called as tangential stress. What is that tangential stress? So tangential stress is nothing but, uh, let us consider the body. Okay, this is the surface of the body. If force acting tangent, like a tangent, okay, whatever arrow mark is a force. If you see, if force act like this, okay, if force is acting on the surface tangential to the surface, then it is known as tangential or shear stress. Okay, all right. So that tangential stress can change the shape of the body. At the same time, it can change the volume of the body also. So let us see basic concept. Strain. When a deforming force is applied, okay, when you apply the strain, or I mean stress, when you apply the stress, it is deforming force, then there will be a change in length, shape, volume of the body. The ratio of change in any dimension to original value is known as strain. So ratio of any dimension, so that may be length or shape or volume, to the original value is called as strain. Okay, there are three types of strain. The first one is a longitudinal strain, second one is shear strain, third one is volume strain. Let us see one by one. Okay, first let us see what is a longitudinal strain. Okay, what is longitudinal strain? Longitudinal strain is if the stretching force, applied to a wire or anything. Okay, here I have, for understanding, I have taken a wire. Okay, you can take a strip, no problem. A material which is having a length L, for simplicity we have taken wire. So wire, or you can take a rod, you can take a rectangular cross sectional rod, circular cross sectional rod, anything you can take. Okay, having a length L. Okay, then length L and having a cross sectional area A. Okay, such that when you apply the force, its length increases by a small L. Okay, length increases by a small L. Then a longitudinal strain is known as change in length to the original length. Change in length to the original length. General definition of strain says change in any dimension, that may be length, volume, whatever, to the original value. So here change in length, that is small l, to the, that is original length is capital L. Okay, okay. And explain tangential stress. Okay, fine. Let us do that. Okay. Okay, I'll go back. All right, I'll go back. Okay. All right. You expect me to explain tangential stress, right? Okay. All right. Tangential stress. So normal stress people have understood, I hope. Okay. So coming to tangential stress, the normal stress. So you understood, force is acting normal to the surface. Okay, normal to the surface. That is you understood. Okay. So now here the deforming force acting tangential to the surface of the body. If suppose say, so this is the body, okay. If you want to understand better, I will show in 3 dimensions. No problem. So this is the body. Now, a force which is acting tangential to the surface, like this. This is the force acting. Okay, a force acting tangential to the surface. Okay, then the force per unit area is called as tangential stress. Okay, tangential stress. So like this force is acting. The earlier cases, so that is normal. The force acting normal. If you again, if you want to understand, if you take a 3-dimension picture, okay, let's take 3-dimension one, right? Force is either pulling force, that is like this, pulling. Okay, two equal and opposite pulling force, then it is known as tensile stress. If it is pushing, okay, pushing, then it is known as compressive stress. So I think that is very clear. Okay. So like this is pushing, pushing. That is compressive. This is compressive, tensile. This is tangential. Is it okay? Karthik, you can put it in the chat. Is it okay? Clear? Okay. 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 Then another request from Vineshri. Let us see that request. So she asked to show the PPT of strain again. What is strain? Strain is when deforming force is applied, the change in length or shape or volume of the body, the ratio of change in any dimension, ratio of change in any dimension to its original value is called as strain. Its original volume is known as strain. Okay. So Mohammed Bilal, check your network. Okay. Check your network. All right. So the ratio of change in any dimension to its original value is called as strain. There are 3 types of strain, that is longitudinal strain, shearing strain and volume strain. Okay. Is it fine? Okay. Let us see the different types of strain, that is longitudinal strain. Longitudinal strain. To understand this, let us consider a material. Let us consider a material. Wire or rod having a length L, and cross sectional area A, such that when you apply the force, F, so what exactly you do? You apply the force. Okay, you apply the force. How exactly you do that? It's a longitudinal, so therefore you pull the body like this with the force F. With the force F, you pull the body like this, then body extends like this, right? Up to this extent, you are going to pull. So length changes by an amount small l, small l. Okay, all right. All right. So the longitudinal strain is defined as strain is equal to L by L, the change in length to the original length, change in length to the original length. Okay, right? So this doesn't have any unit that you can understand, because this is also length, this is also length, this is also in meter, this is also in meter. So therefore there will not be any unit for this. I hope this part is clear. Okay. Any question at this moment? You can put it in the chat box. No question. Okay. All right. Before going to, yeah, I will launch the attendance poll. Yes. So there is a poll open. So you can answer your attendance. All right. So coming back, uh, let a tangential force, okay, now force is tangential force F is applied on the surface. Okay, so for understanding, okay, here you see, so a tangential force, so in which direction it is applied? So what exactly you have done is, so let me take the pointer. Okay, so whatever body is, shape is A, B, C, D is the body. You can see this. This is the body. Okay. So you are applying the force, a tangential force. Okay. Raviraj, for which one you are asking for? Spring is also can be considered. Yeah, I think your previous one, previous one. Okay, you can consider. There is no issue. Longitudinal stress. Longitudinal stress. Yes, you can consider. There is no issue. Even you can consider spring also. Okay. But of course, their cross section slight modification you have to do the in the formula. Okay. but you can use for the spring also. Same thing is true for spring also. Okay, all right. Coming to shearing strain, let us consider a body. A shearing force is applied on the top surface. Let us say bottom surface is fixed. Bottom surface is fixed. Okay. Then what happens? When you apply the tangential force to top surface, then body deforms. Then point A displaces to A dash, B displaces to B dash. Position changes because tilted. Body is tilted by an angle theta, by tilted or sheared. Okay. The cubical body is sheared by an angle theta. Bottom remains same, but the top sheared with respect to bottom. Okay, let us say height of this is L. Height of this is L. The amount of shearing, that is length A dash or B dash, let us say L. L is the length. Okay, so then shearing strain is defined as, shearing strain theta is defined as tan theta is equal to L by L, small l by L. L is original length, that is height of the cube, height of the cube. L, small l is the amount of shearing, amount of shearing. Theta is the angle of shear. Okay, shearing strain is defined as tan theta is equal to L by L. Okay, so there are another type of strain that's known as volume strain, or it's also known as bulk strain. It's known as bulk strain. Okay, so let us consider a force F acts normally over a body. Okay, something like this. So consider a body. Force is acting normally from all six direction, all six phases. Whatever body I have considered is a cube. Okay, cube I have considered. This is subjected to a force which is acting normally over a body. So how it is acting? How it is acting? The force is acting in such a way that volume of the body, this is the body, original volume. Okay, let us say capital V is the original volume of this body. Now force F is acting. Force F is acting. How it is acting? This is acting in such a way that, all six phases, yes, all six phases of cube is experiencing a force F. Because of that, the volume changes by an amount of dV. By an amount of dV. Now volume changes. Okay. So volume changed by an amount of dV. So therefore volume strain is defined as, volumetric and volume strain one are the same. Volume strain or bulk strain is defined as change in volume. What is the change in volume? You have defined it as dV divided by original volume. Divided by original volume. That is known as bulk strain. That's known as bulk strain. So what are the things we have seen so far? We have seen what is elastic body, what is elasticity, what is a plastic body, what is plasticity, and we also understood what is perfectly elastic, what is perfectly plastic body. Then we understood what is stress. Then we have understood what are the different types of stress. There are normal stress. Then, okay, there are two types of normal stress. Then tangential stress. Okay. Then we have seen what are the strain. Strain. There are different types of strain we have seen. Okay, longitudinal, and previous one is shearing. Okay. Then we have seen bulk or volume strain. Okay. So these are the we have seen. Any doubt? Any doubt up to this point? Negative sign. which slide you are talking about, Karthik? Previous slide? The volume strain you are talking about? Negative sign. Karthik. Okay. Okay, what I will do is, I will unmute. Let me unmute Karthik. Okay. So let us see next one, next concept. That is Hooke's law. Hooke's law. You know this, even if I don't ask, also you know what exactly Hooke's law. Anybody, can you write the statement of Hooke's law in chat? Yes, what it says, Hooke's law says, stress is directly proportional to strain within the elastic limit. Within elastic limit, stress is directly proportional to strain. That's what exactly Hooke's law says. Of course, the important thing is elastic limit. Elastic limit is the important thing. So, stress is directly proportional to strain, or you can write uh, stress is equal to some constant into strain, that can be written as stress by strain is equal to a constant. Okay, so constant, let us designate it by E. Okay, let us designate that constant by E. Okay, all right, this constant is called as modulus of elasticity. This constant is known as modulus of elasticity. Okay, or it's also known as coefficient of elasticity. All right, constant is known as modulus of elasticity, or it's known as coefficient of elasticity. The maximum value of applied force up to which the body regains its original shape and size is called as elastic limit, because our Hooke's law is valid within the elastic limit. Within the elastic limit, Hooke's law is valid. So therefore, what exactly elastic limit? Elastic limit is nothing but it's the maximum value of applied force up to which the body can regain its original shape and size. So after certain force or applied force, what happens is body will not regain its original shape and size. There will be a permanent deformation. Permanent deformation. That is known as plastic deformation, of course. So that the limit up to which body will regain its original shape and size is known as elastic limit. Okay. So yes, it is already 12:52. Okay, no problem. So let us see the stress strain curve. With that, we will stop for the day. So whenever material, yes, all right. This is a stress strain curve. Whenever material is subjected to stress, then what exactly happens? Material undergoes deformation. Material undergoes deformation. So how exactly material undergoes deformation? So if you we'll take a pointer, let's say a strip you take, just recall maybe rubber band you can recall. Okay. So when you stretch this, so this end let us say fixed, this end is fixed. Okay, this end is fixed. So I'm pushing at this end. I mean pulling. So I will stretch this end. So then what exactly happens? So the length goes on increases. So as length increases, what happens to strain? Strain also increases. Strain also get increases. That's what exactly shown in the figure. Okay. So what is shown is as stress increases, strain is also increases. The important part is first one. It is OP, region OP. You can see that it is linearly increasing, a straight line. Linearly increasing. So in this region, as soon as you remove the stress, the material comes back to original point. That means it is elastic behavior. It is elastic behavior. So up to OP, it obeys Hooke's law. Stress is directly proportional to strain. Straight line means it is a Hooke's law. That means we say it is proportional region. Proportional region. And P is a proportional limit. P is the proportional limit. But important point is, after P, even if you apply the stress, material undergoes a deformation, but it is not a permanent deformation. If you remove up to point Q, but it is non-linear, it is not directly proportional, stress is not directly proportional to strain. So it's a non-linear region. Okay, it is non-linear region. So, but it will go up to continue to exhibit elastic property till point Q. Okay. If you remove stress at point Q, again it will come back to point O. Point O. But only thing is stress is not directly proportional to strain in the region P to Q. But this is the limit. Q is the important part. Q is the important part. What is the importance of Q? If you still apply the stress beyond point Q, then what happens? Then there will be a permanent deformation. Then there will be a permanent deformation. Whatever deformation takes place, that will be permanent. Okay. So there will be a small amount, even if you remove the stress at point R, it will not come back to O. It will not come back to O. Then it will come somewhere here. This dotted line. Okay. So therefore, Q is known as yield point. Q is known as yield point. Up to that point, even if you apply stress up to this point, body can regain its original shape and size. Okay. So that is known as yield point. Okay. Then here that plastic behavior starts on further applying stress. So there is a permanent deformation up to point S. At point S, the material cannot withstand the force, I mean stress. So material will break. Material will break. Okay. Q to S. The body will fail at point S. Okay. So of course, whatever this inside the dotted line, I already told permanent deformation, that is permanent set. So this region, even if you remove somewhere X, if you remove the stress, the body will regain, but come to this point, not complete regain. Okay. So point S, it's a fracture. Then of course there are 2 points, that is a peak from R to X, that is known as strain hardening region. X to S, that is known as strain softening region. If you carefully observe the curve, what you see is as you increase small amount of stress also, strain, there is an increase in strain because here material become hard and hard and hard up to point X. You can see more amount of stress is there. Whereas suddenly after point X you can see that there is a strain softening, that is that goes on decreases amount of stress required to obtain higher strain, that is decreases. That means material behaves as if material becoming softer and softer, softer and softer. So therefore that is known as strain softening. This region is known as strain hardening region. There's more about this we will discuss in the coming class. Okay. So here it is not required. We will discuss that separately. Here if I even if I discuss what is strain hardening, strain softening, you don't understand clear. So therefore that we will see later. Okay. So with that I will stop for today. Okay, so that's about stress strain curve. Next, we'll see modulus of elasticity in the next class. Okay, all right. So, how many of you have joined? Let me check. Only for today, 42 people have joined. Remaining have not joined. Okay, all right, no problem. 41. All right. So thank you for joining in a new platform. Let me know before leaving. Let me know. Do you know want unmute option yourself? Put it in the chat box. You want unmute option yourself. Okay, okay. If it is required, no problem. I can provide you. Next class I will activate that. Actually, I have activated in between, but I don't know why it is uh, not worked. Let us see that. Video is not allowed. It is blocked. No video is there. Only host can uh, uh, have the video. Attendees, your student cannot have the video. So therefore, video is blocked. Okay, video is not necessary, na? Because even otherwise, video means it is a big problem. So it will consume a lot of bandwidth. So that is why we are not using video. Okay, all right. Thank you for joining the class. We'll see you tomorrow.